Oh, welcome and thank you for joining. In this lesson, we'll explore the addition and subtraction of rational expressions. The goal of this lesson is to learn how to add and subtract rational expressions, but also write the final answer in the most simplified form. And remember, the most simplified form means that all the common factors that are present to both numerator and denominator are simplified. Now remember that to add fractions, we need to make the denominators the same as the lowest common denominator. And to add rational expressions, we'll have to make the denominators the same as the lowest common denominator. Now recall that the lowest common denominator is the lowest common multiple of denominators. So let's take a look at some examples just to refresh our memory. So if you have to find the lowest common multiple of numbers 2, 10, 15, and 6, we first list all the possible factors of each of them. So for number 2, we have the prime factor 2. For number 10, we have the prime factors of 2 and 5. For number 15, we have the prime factors of 5 and 3. And for number 6, we have the prime factors of 2 and 3. So notice how we listed the prime factors right below each other, the common prime factors right below each other, because that makes it easier for us to determine the lowest common multiple. And we're going to say that in this case, we'll have the lowest common multiple equal to 2. And then that will multiply 5. And that will multiply again number 3 here at the end. And we're going to say that 2 times 5 times 3, which is equal to 30, is the lowest common multiple. And what that means is that the lowest common multiple of 30 is divisible or divides evenly into all these numbers. So 30 divided by 2, 15. 30 divided by 10 is 3. By 15, 2. By 6, 5, and so on. So you can try one more. So here we have the numbers 12, 5, 3, and 2. So I'm going to list these numbers below each other. Now, some lowest common multiples are kind of easy to find. They're common sense when the numbers are smaller, but I am explaining the entire strategy here. That's why I'm showing the longer way. So number 12 has the prime factors of 2 times 2 times 3. Number 5 has a factor of 5. Number 3 has a factor of 3, and number 2 a factor of 2. So the lowest common multiple then will be equal to, so we're going to start off with the first one, which is number 2, multiplied by, we have another factor of 2. So it does have a special spot because it's a separate factor. And then we have a common factor of 3, and then a common factor of 5 at the end. And we're going to say that in this case, the lowest common multiple would be equal to 2 times 2, 4 times 5, and then times 3, so 20 times 3, and that would be equal to 60. So what that means is that number 60 is the lowest or the smallest number that is divisible by all 4 numbers here, numbers 12, 5, 3, and 2. And that's the idea of the lowest common multiple. Now, whenever we say the word lowest, it's a kind of instinctual that people will think that it has to be a number smaller than that, but no. Lowest common multiple is the smallest multiple of all these numbers, okay? Now, to find the lowest common multiple in algebraic expressions is somewhat easier than in numbers. So for example, if we have x squared, 2x4, and 7x to the power of 2, then I'm going to do the same thing. We are going to discover shortcuts very soon and very easily, okay? And we're going to do this a lot faster, but I'm showing all the steps in the process because I want to explain and make it clear and visible to us what's hiding behind all those shortcuts that we are sometimes taught and we tend to memorize. Remember, memorizing, it's a good thing, but the best way to learn is by understanding why things work the way they do. So, x squared has 2 factors, x and x. 2x to the power of 4, so it has the factors x times x times x times x times 2. I left the constant at the end, doesn't really matter. So 7x to the power 3 has x times x times x, and then times 7. And when we find out the lowest common multiple, then we're going to say that that would be equal to, so here we go, we have x first, and we have another x in here, and then we'll have another x in here, and then we have this lonely x in here, and then we're going to bring the number 2 in here, and then lastly we have the 7. So I'm going to write them down. So we have the blue x and the yellow x and the brown x and this other blue x and the number 2 and the number 7. All of them multiplying each other will give us the lowest common multiple. So we have 14, and then we have x to the power of 4. So if you want to look at it like in a more concise way, then you're going to say that the lowest common multiple would be equal to the lowest common multiple of the coefficients. So if you have 1, 2, and 7, the lowest common multiple of them will be 14. And for the variable part, we're going to need to include x to the highest power, because remember, the lowest common multiple is that big term that is divisible by all of the terms that participate in this, list of terms where we're finding the lowest common multiple of. And obviously we need to choose the highest power so that it can be divisible to this by this. So remember that 14x to the power 4 now is divisible by x to the power of 2. And if you divide 14x to the power 4 by x squared, you're going to get 7x squared. Now, 14x to the power of 4 is also divisible by 2x to the power 4. So you see you're going to get 14 over 2. Sorry, I made a mistake in here. Salimia was thinking about the previous question, and 14 over 2 is 7. X to the power 4 by x to the power 4 will simplify there. And 14x to the power 4 divided by 2x to the power 4 is 7. And now we have 14x to the power 4 by 7x to the power of 3. That would be equal to 2x. So as you can see, from the divisions, we get, terms that don't have complicated fractions or, negative powers. So the powers have to be positive or 0, like in this case in here. Now, let's take a look at another example. You can try this on your own, but I am going to go over it, so in case you want to follow with me. So if you have 3x squared y, so that means that we have 3x squared y equal to 3 times x times x times y. And then we have 5x squared y 4. So that means we have 5 times x times x times y. And we're going to have 4 y's multiplying each other. And 6x squared y squared. So here we're going to have, I am going to actually do something a little bit differently. I'm going to bring the number 3 in a special spot. Okay. So... And because I don't want to interfere with number 5, it's not a big deal. So for the term 6x squared y squared, we have x times y times y. And 6 has the factors of 3 and 2. And that would be it. So if you want to find the lowest common multiple, then we're going to say that we will have the number 5. So we can bring this down here. And then we have this x. And then we have this other x here. And then we have the y. And then we have this other y in here. I don't know, the colors kind of change here, but doesn't really matter anyways. So we have the y times y here. And then we have this other y in here, which we're going to bring down. We have this y down here as well. Let me find a different color for it. Here we go. And we're going to have the number 3 that repeats as a common factor in 2 different spots here. And that lastly, we have the number 2. So what you have in here is 5 times 3 times 2. That is going to be equal to 30. X will be to the power 2 and y will be to the power of 4. So again, if you want to do this, the shorter way. So you look at 3, 5, and 6. The lowest common multiple of it is going to be 30. And then we look at x squared, x squared, x squared. So that would be x to the power of 2, part of the lowest common multiple. And here we have y to the power 1, y power 4, y power 2. And we're going to say y of the highest power will be the part of the lowest common multiple. So this is what happens when we have monomials. And what we're going to do is, now we're going to get started with adding and subtracting some rational expressions. I wrote down the steps in here, but I'll explain the steps as we go through the examples. So example number 1, we have rational expressions, additions, subtractions. Now in this case, denominators are the same, which means that we're ready to start adding and subtracting. And before we add and subtract, we can always start stating the restrictions. In this case, a very simple example, we can go ahead and simplify the 3 fractions. So operate the numerators, denominator is the same. 3 plus 5, 8 minus 2 is 6 divided by x squared. So we haven't simplified anything, which means that it is safe to start stating the restrictions. And we have x squared in the denominator, which shouldn't be 0, which means that the restriction is x different than 0. Now check and see now if you can simplify anything. We don't actually, so that would be the final answer. So we're going to say that the final answer is 6 over x squared, where x has to be different than 0. So this is an example for you to try. As you can see, the denominators are the same. So what that means is that we can start by subtracting the 2 expressions. So denominator will stay the same. We just operate with the numerators. So 4x minus 1. And then you have minus x plus 3. So when you are subtracting, right, a binomial or a polynomial with 2 or more terms, it is very important to be mindful of the fact that every term will be subtracted. And the safer way to remind yourselves is by keeping this in brackets. So we are going to simplify 4x minus 1 minus x minus 3 over x plus 2. So keep simplifying a little bit more. You have like terms in here, so 4x minus x is 3x, negative 1 minus 3 is negative 4, divided by x plus 2. So once you have added, then you can start stating the restrictions. In our case, we have x plus 2 in the denominator, which means that has to be different than 0, which can happen only if x is different than negative 2. So this is going to be the restriction in our case. And then lastly, we have to check and see if there is any simplifying that is likely to happen here. And I see that nothing is factorable, and I don't see any common factors, which means that this must be the final answer. So the final answer is 3x minus 4 over x plus 2, where x has to be different than negative 2. Now, in the next set of questions, we're going to take a look at some expressions where the denominators are numerical. Numerical, but they're not the same, right? So we will have to start off with lowest common denominator. And I know that we have actually mentioned in the first lesson on rational expressions that this cannot be treated as a rational expression. This is just a polynomial, right? But the purpose of this exercise is for us to learn how to gradually adjust or to get used to adding and subtracting the rational expressions correctly. So I'm going to start with numerical denominators because that is something we are more familiar with. So the lowest common denominator of 4, 8, and 6. Again, you can go the long way or the short way. It doesn't really matter as long as you are writing the lowest common correctly there. But number 4 is 2 times 2. Number 8 is 2 times 2 times 2. And 6 is 2 times 3. So we have a 2, a 2, another 2, and a 3. So that makes the lowest common denominator equal to, well, this is the lowest common multiple, right? Which is equal to 24. So the lowest common denominator is 24. So next, what we want to do is make all these denominators the same as the lowest common, which is 24. So if you want to make a 4 into a 24, you know that you have to multiply by a 6, which means that the numerator gets to be multiplied by 6. If you want to make 8 into a 24, you got to multiply it by 3, which means that x minus 8 must also multiply by 3. And for number 6, we're going to need to multiply by 4. So then we have to multiply by 4 the numerator. So technically, what we have done is we have divided the numerator and denominator by 6. In this case, 6 over 6 is basically equal to 1. So that hasn't changed the value of this expression. And same thing with the next term. So 3 over 3, that's 1. 4 over 4 is 1. Remember, we cannot get rid of fractions. This is not an equation. It's an expression. So all we are allowed to do is change the way it looks, but don't simplify the coefficients. So don't eliminate them. So I'm going to rewrite this a little bit more neatly. So what we have in here is 6 times 3x plus 2 over 24 now. And then plus 3 times x minus 8 over 24. And then minus 4 times 2x minus 1 over 24. So since all denominators are the same, it means that we can start simplifying. So we have 18x plus 12 plus 3x minus 24. So 18x plus 12. 3x minus 24. And now, very careful, this minus sign will belong to this monomial here, and it will multiply every term inside the brackets, which means that we're going to have minus 8x here. And then the minus 4 times minus 1 is going to be plus 4. Okay? And next, we will simplify the numerator, collect like terms, 18 plus 3 minus 8. That would be 21, and 21 minus 8 is going to be 13x. And 12 minus 24 plus 4, that's a negative 20, plus 12 is going to be minus 8 over 24. Last, we want to check and see if we have to, or if we can simplify anything. And for this, we need to find any common factors. And as you can see, there are no common factors between numerator and denominator. Remember, 13x is a term, negative 8 is a term, and negative 8 and 24 cannot simplify because that's a term, not a factor. And we have emphasized this so many times in class, and I hope you won't forget that. Now, the next question is, do we have to state restrictions here? Well, obviously, what we have in here is denominators in numerical form. We already know their value. We already know they're non-zero, so we don't need to state any restrictions. Okay. Now, I'm going to leave the next example for you to try on your own. Okay. And it is done the exact same way as in example number 2. And I will be posting the notes online in class so you can check your answers. Now, next we are going to look at some very interesting examples. This is when we simplify or we add expressions in cases when we have to factor -1 from the denominator. So now, we've mentioned in class how opposite numbers are numbers that have same value but opposite sign. For example, 3 has an opposite -3, or -100 has the opposite +100. Now, same thing applies to terms. So if you have x squared y has as opposite -x squared y. And negative ABC will have as an opposite positive ABC. Now, when it comes to binomials, that looks a little bit more, how to say it interestingly. So if you have, let's say, a binomial of the form a plus b, the opposite, so you follow the same principle, will be the opposite of a plus b, which is negative a plus b. And in a more simplified form, we say negative a minus b. So these two are opposites, we're going to say, all right? Now, if we have something in the form a minus b, the opposite will be negative a minus b. And when you remove the brackets, that's negative a plus b. So we're going to say that the opposite of a minus b is negative a plus b. And I want us to stop for a second and take a look at this. So as you can see, a, negative a, opposites. Negative b, positive b, opposites. So when terms in a binomial are opposite, respectively opposites of each other, then the binomials are opposites of each other. Now, why do we need to actually mention this, and what is the importance of separating this from the rest of the questions, so studying it separately? Well, there is something interesting about opposite numbers, and if you were to divide a number with its opposite, the answer will be negative 1. So if you have x squared y divided by negative x squared y, the answer negative 1. And if you have a minus b and you divide by negative a plus b, guess what? The answer will be negative 1. And then when it comes to polynomial expressions that are opposites of each other, that helps us simplify a lot faster, okay? And not to mention that sometimes these kind of opposites that can be part of an expression are hiding under this format. So a minus b over b minus a. So if you have a minus b over b minus a, you should be able to recognize that each term is an opposite of the other, and the answer here will be negative 1. So with this in mind, we're going to move on to our example 3. And I titled these examples by factoring negative 1 from the denominator. So as you can see here, we have a rational expression added to another one. When we add, we need to find lowest common denominator. When you look at these denominators, notice that they kind of look the same, but not exactly. So you have x in here, negative x, negative 7, positive 7. So they are opposites of each other. So one way to tackling this kind of problem is by rewriting the expression with the terms in the same order. And correct same order means from highest to lowest degree. That's normal math routine. And then you will have 4 over x minus 7 plus 8 over negative 1 x minus 7. So now it's kind of easier for us to see that x minus 7 is a common factor in the denominators, which can help us find the lowest common denominator more easily. Now you're probably wondering, how about this negative 1 in here? What do we do about it? Well, I think it is more practical and it is easier if we bring that negative 1 at the top, because you know that if you have 8 over negative 1, that's the same as negative 8 over 1, or same as negative 8 divided by positive 1. So these fractions have exact same value. So in the next step, and normally you don't have to show all these steps, again, that is because we're trying to explain how things are moving here. Then what I would prefer to do is bring the negative 1 here at the front of the fraction and rewrite the rest as 8 over x minus 7. So that makes my life easier, because now I can see the lowest common denominator is x minus 7. Or should I say that they have the exact same denominator, and I can just start simplifying. So the lowest common denominator is x minus 7, and normally in the lowest common denominator is where the restrictions will hide. And the restriction will be x minus 7 different than 0 and x different than 7. So here we go. We stated the restrictions, and then we are going to simplify. So operate, simplify the numerators, keep the same denominator, negative 4 over x minus 7. That's as simple as it can be, and we're going to state that x shouldn't be 7, and that's the end of story. Now, in the next question, you have something similar, and I encourage you to do this on your own. And I am going to try to do this, actually continue explaining in here if you want to follow. And I'm trying to do this a little bit faster, assuming that now we know what we're doing. So x minus 5, 5 minus x. So x, negative 5, positive 5. So these two are opposites. So immediately, then you're going to say that that's negative 1 over x minus 5, because they are opposites of each other. And you see that the negatives in here will make a positive. So we're going to say that's 13 over x minus 5 plus 2 over x minus 5. And x minus 5 is common. And we just work with the numerator. And we have 15 over x minus 5. And we're going to say that the denominator, we haven't simplified anything out of the denominator, is x minus 5, and the restriction is going to be x different than 5. So you can add this at the final statement down here in the most simplified form. Now, if you're thinking that 15 is divisible by 5 here, then you're thinking it wrong. So please don't make this mistake. I know I keep emphasizing it very often. Remember, negative 5 is a term. 15 is the only term in the numerator, which makes it also a factor of the numerator. So a term and a factor a term and a factor do not simplify. They have to be both factors. So this should be the most simplified form of it. So this was part 1 of adding and subtracting rational expressions. There is more to come in part 2, for which we're going to dedicate an additional class. And I hope you found the instructions useful. Please don't forget to practice. The more, the better. So thanks for listening and working and learning with me. Bye for now.